Diffusion and convection. Once you make these films, they make a delightful two-dimensional sheet of water in which to do other experiments with. Here we are using food coloring to look at the role of diffusion in a two-dimensional sheet of water. And the food coloring drops just stay there, and you can slowly see the effects of diffusion making the edges fuzzy. You can puff air on this sheet like we are doing here with a syringe, and you can move the food coloring around. This movement makes a nice sharp edge. When you quit puffing, viscous forces dampen the motion, and you're just left with this structure. This is a panaway in our wet chemistry lab, which is set up in the Russian FKB module. For our video background, we use one of our cleanest dirty towels, or for the blue background, we'll use one of our cleanest dirty shirts. Here we are panning edgewise onto this sheet to show indeed it is very much a two-dimensional structure. These sheets are quite stable. We've kept them around for well over a month if you retard the evaporation, which tends to thin them. Now here is this sheet with the food coloring after about an hour, and you can see the edges are fuzzy due to the effect of diffusion, which operates rather slowly. If you puff on it, you incite convection due to the bulk fluid motion, and that sharpens the edges once again. Now, we're going to investigate tracer particles with induced convection. These are mica flakes, 5 micron diameter, in a water suspension. We put a couple drops on one of these sheets, and now we are intentionally inciting rotational flow within the plane of the sheet by giving it a little stir. And this motion now, this rotational motion, will continue for about a half hour before viscous forces dampen it down. And we're seeing streak lines being left by the tracer particles. And we will soon go into a time-lapse mode here where about 10 seconds of playtime is equal to 1 orbital period of 90 minutes. You can see that the pattern rotates in one direction for a while. It'll stop and start to rotate in the opposite direction. This is due to the residual acceleration forces on space station. You can also see that diffusion is slowly making the streak lines diffuse with time. So now the question is, what can we use these for doing other fluid mechanic experiments where you can capitalize on having a two-dimensional sheet of water for doing fluid mechanic experiments?